Cool, thank you very much. So I'll make a little start just to kind of introduce myself, and I'll hand over to Nathaniel. My name's Toby Lewis. I'm Darktrace's Global Head of Threat Analysis. I spend most of my time running our Analyst team that dives into all the data that Darktrace deployments all over the world collect in, run SOC as a service, provide consultancy services. I haven't always been a somewhat filthy vendor. Prior to joining Darktrace, I was in the sort of formation of the NCSC and going back beyond then, many of sort of the predecessor organizations, spending a lot of time in incident management, threat intelligence, and I suppose a few other things as well.
Yeah, thanks, Toby. Yeah, Nathaniel Jones. Hi, everyone. I've been with Darktrace for about 3 years now, so I've run the threat research team alongside Toby. Prior to that, I was within US government CISA. For about 7 years, doing incident response, mostly around China intrusions, but sort of the big four, and before that, Capgemini and Deloitte. So here we go. I'm gonna go the other way. Oh yeah, one more.
Okay, so what we want to kind of talk a little bit about today was to try and really take apart some of the conversations around using AI in cybersecurity. And I think part of that is quite often the challenge that AI has become this ubiquitous buzzword for, well, everything that you might call AI. And the reality is that it's not quite as simple as just using AI, but about trying to really think about what problems you're trying to solve and utilize the right AI techniques to do so. So there's a little bit of, I suppose, understanding of AI techniques that are available, because not all are created equally. So the way we sort of think about it from a Darktrace perspective, and certainly if you think about, if you were to look at most modern literature today around AI, you would think that actually the world is just populated by large language models, generative AI, and that's really what AI is. But the reality is it's a whole lot more than that. From our perspective, we spend a lot of time trying to work out, well, actually, if we've got a lot of data coming in, how can we do better at processing it? And so we've got this pyramid layer that we have here, and this really talks about the different stages, the different types of understanding that we go through to try and work out whether AI is the right tool to use or not. And so we start off and we bring in loads of data, and this could be telemetry data, network data, emails, and we're spending time building out patterns of life, using things like Bayesian models to understand what does normal look like for that environment. Effectively, we are training our AI on the good data, the real-world defenders that are out there, rather than saying, this is what bad looks like, go find it. So we're learning what normal looks like. And then we're starting to look at things like, well, are there any anomalies in there? Are there any strange clusters? And not just at an individual level, but say, this team over here, they all do all the same sort of work, except that one PC is now doing something unusual. So within a cluster, are there anomalies? And then maybe expanding even further, so are there anomalies across the whole environment? So again, 99% of the organization does this, but there's one device over here that's doing something slightly different. And then we use other AI techniques to overlay on top of that are not just about anomaly detection, but trying to understand behaviors. Are there certain ways in which they're working that we can start to classify? And then we're looking at techniques such as graph theory, for example, where we then start to glue anomalous events together. Because ultimately, anomalous events, if they really are bad, don't just happen in isolation. You know, we're all a little bit weird. I think we can all accept that. Human beings are a little bit weird. We, maybe one day we log on to work a little bit early. Maybe we're traveling with work. Maybe you're traveling up to Scotland. Just because you logged on at a weird time of day or from a Scottish IP address doesn't necessarily mean that it's the end of the world. But if all of these things start to happen, and then something else happens, and then they're now accessing data they wouldn't normally access from a server they wouldn't normally access, downloading and uploading things that wouldn't make sense for that individual, suddenly that clustering of anomalous behavior suddenly becomes a whole lot more interesting. And so from a Darktrace perspective, what we're doing is we're bringing in that data in first and foremost. So over here on the left-hand side, a whole realm of data about your environment, whether that's about the network traffic that exists, whether that's emails, OT, you name it. If it generates telemetry of what's going on, we will consume it in one way or another. And then at that point, it's then moving through different stages of AI-based processing to understand, is this pertinent or not? Whether that's Bayesian classifiers to understand anomaly-based detection. Is this what we'd expect to see? And then moving on to a sort of a hypothesis editor, where we're running through attacker tradecraft to go, could this be brute forcing? Could this be lateral movement? And at each stage, scoring it based on the most likelihood of probability. And then on the right-hand side, we have AI Analyst. And actually, if you want to think about what most people consider AI, the large language models, the generative AI, it's really only at that point we even start to consider some of those techniques. Can we present information about this incident in a way that's a little bit more understandable? And of course, that's great in terms of detection, that's great in terms of identifying what might be going on, but it would also be great if we could do something about it. And so we have some capability to do that as well.
Nice, thanks, Toby. Yeah, so now that you guys understand how we apply different levels of AI, we wanted to talk through, thank you, the threat landscape and what we see. So for Darktrace, 10,000 customers, and so we're all over the world. And so what are we seeing the last year, and how is it impacting how defenders are sort of reacting to the situation? And again, it breaks down to different regions, right? In the US, a lot of deep SaaS adoption, and so you see a lot of SaaS compromise. That's a big one. For Europe, you see cloud and email, and that sort of cloud-first shift has sort of led into, those levels of compromise that we see continuously. And so one of the things now in terms of Europe is not just at sort of manufacturing sectors and different C&I, but also in terms of for the UK, what are those sort of threat actors looking at? And we had a really interesting case maybe 6 months ago about contagious interview, which is, for those who are not familiar, DPRK, North Korean actors using sort of lures for job interviews and using AI within that interview system. And so in this case, we saw it in our own customer portal, had a really interesting ticket where a UK blockchain company had a developer who got an invitation from a North Korean actor, did an interview, and then was asked, hey, can you download this thing into OneDrive so you turn on your camera because it's not really working? Right? And a bunch of other different anomalies had gone through that. But it's interesting to see how threat actors are impacted in the UK, but also globally. I think for us, we've seen a few different takeaways in terms of identity and what that means, right? In terms of, for Toby and I, maybe we have 40 or 50 different sort of identity artifacts, but also my agent, and why is my agent going to talk to Mike Beck, our CISO? What's going on there? So how do you correlate and understand what's going on? And so an identity that just amplified in terms of cloud and SaaS and email. But I think also because AI is in the game in terms of vulnerability research and how that's impacting sort of the threat landscape, we kind of want to talk about the benefit of having an anomaly-based detection tool. So in this case, we're seeing a lot of explosion in terms of vulnerability the last sort of 20 years, right? In particular, the last 5 years. And so 2024, you saw 40,000 sort of CVEs identified. 2025, 47. This year, we're on pace for 57,000. And so it's just interesting just for us to see that outplay. And then from a threat research perspective, how we sort of understand those behaviors. So we look at sort of CISA's known exploited vulnerability database, understand what's been exploited. A lot of these are sort of regular players within that sort of database. And what we have benefit is going back to look back and see what those are.
So I think what's really important to recognize, and what are the challenges that defenders quite often get asked, and certainly we get asked on a regular basis by our marketing team, is how many 0 days have you spotted today? It's a really, really hard challenge, right? How do you detect a 0 day? How do you detect the use of a novel technique? And I'll be brutally honest, right? The way we tend to do it is we let somebody else find it fundamentally first, talk about it, blog about it, and then we hit the rewind button. Did we see this? Did we see this in any of the environments that we have? Was there any indicators that might have given this away? And generally speaking, the graph that you can see on here is actually where anomaly-based detection, overlaying classifiers on top, we're able to spot anomalous behavior, unusual behavior, concerning behavior, often days, if not weeks, in advance of the actual 0 day becoming public. And so from our perspective, that race condition, if you like, for defenders, do you always need to know what is bad out there to be able to detect it? Well, the short answer is no, you don't. And actually, that's the model that we've proved time and time again from a Darktrace perspective. So to talk through a particular example of one that we sort of caught quite early on, Ivanti, I mean, since COVID, we are pretty much all working from home. Remote access solutions, VPN solutions have become the go-to platforms for attackers to exploit to gain access into enterprise environments. And Ivanti here is absolutely no different. This was originally published by Ivanti and security researchers around January the 8th, 2025, and this is when mass exploitation was taking place all over the internet. And when that came out, as a team, we went away and said, look, did we see any examples of this before that date? Can we start to work out when the attackers maybe first had developed that tradecraft, where they first got access to that capability, and maybe who were they going after in some of the early stages? And so we started to understand where we had proven examples of attackers using this capability. Okay, where else do we see the same behavior taking place? And actually, we were able to sort of rewind the clock a little bit, going back just into the end of the previous year, December 29, 2024. Very clearly, we were starting to see some of the early stages of these exploits being thrown, and Darktrace's ability to detect that as fundamentally anomalous for that environment. One of the great benefits for a lot of the customers at the time we had is that I mentioned that ability not just to detect something, but also do something about it. And so that built-in containment we have, which is firing on anomalous behavior, meant that we had customers that were having Ivanti exploits thrown at them. It looked anomalous, so we locked it down. Even before that 0-day, even before that CVE really became public and more worrying for the rest of the community. What did that look like in Darktrace? So if you think about it from a classic SOC environment, you've got this example here, just a whole load of alerts coming through, lots of individual kind of issues of here's an anomaly, here's an unusual thing, this is weird, this is strange. And to a SOC analyst, this is just, or can just be absolute overload. Which one of these is actually interesting? And so yes, whilst use of AI here gives us some advantages in catching behaviors that are unusual, it's then clustering activity, graph theory, that allows us then to bring some of those together and say, hey, all of this weird activity, yeah, it's probably all related to the same thing. And then starting to map it out with sort of visualizations, write-ups, explaining it, using other variations of AI to really put it in front of the defendant and go, you might want to investigate this. We don't know what it is. We don't know if it's a 0-day or novel or new. We just know it's really weird in your environment and you want to look at it.
Nice, thanks, Toby. And so we've talked about a little bit how use cases for AI in different ways, either in your own systems, but also for Europe and UK, and what we see across our customer base. And so for me, I wanted to do sort of a different project around China. I lived in China for 3.5 years, did a stint at the US Embassy in Beijing, and sort of really, how can we apply different levels of AI into still a traditional threat, in this case, China, right? And so we did a report around Crimson Echo, and those key takeaways are probably not too new, particularly if you're ex-government, in terms of how they look at cyber and strategic planning and sort of those different intrusions. And so what we found was we've had about 80 different cases over 3 years. We looked at how those intrusions were operating, behaving in terms of the short dwell time and sort of the low and slow and what that meant, and also in terms of some of the challenges for Western security models and what that meant in terms of China. So, and for us, the smash and grab and the low and slow looked like this, right? For rapid exploitation on Ivanti, or the latest vulnerability, right? And the median time horizon was 10 days. They had a detection tolerance that was rather high. You see it in the news. People point out China probably did this. Do they really care? There's no blowback for them. And the low and slow is interesting because we see an initial anomalous behavior, and then they'd go quiet for a long time. Really low and slow. And we had a really few interesting cases where they entered into sort of a UK high-value target or a US high-value target and didn't come back for, in one case, 600 days. So it's been interesting to see that and how AI is able to sort of pick up on that behavior. And so in this case, we also have China sort of using exploiting SAP. And this is just a timeline about what sort of the AI agent was able to understand what the Chinese threat actor was trying to do in that sort of UK CNI environment. And this was before the actual exploit, or vulnerability rather, was published. And in this case, you had about 6 or 7 days. So about a week for the defender to understand, there's a vulnerability, it's being exploited. Now I have about that time back to me. And so that just walks you through in terms of unusual DNS, right? And so unusual PowerShell, those sort of things hitting you in the face as a defender. And we have another case in terms of, as Toby talked about, autonomous response. It's really helpful to detect it, but if you can't contain it, what's the point, right? And so for us, using that sort of containment mechanism, in this case, what we call autonomous response, being able to see that and stop that, that because of patterns of life, because of our applications of different levels of AI. And this one, another sort of China case, state-linked malware.
So one of the things we spent some time looking into was a cluster of activity related to ShadowPad. This is a set of malware activity very heavily linked to state behavior. And I think from our perspective, we were able to kind of map out different stages of that kill chain path. What was the threat actor getting up to? How did they move laterally? How did they expand their coverage? And at each stage, we were able to determine that ultimately it constituted some form of unusual behavior for those environments, things that we could start to identify a little bit of pattern of behaviors for. Now, if you think about what that would sort of typically look like within that SOC environment, as I said, on the left-hand side, you've got alerts going off one after the other. You've got those analysts that are trying to just mentally pull all that data into their heads, understand what's going on, and then go, well, what does this mean? They might be on this middle section here trying to bring in all the sort of the much more technical detail, all the individual logs, all the individual bits of telemetry, trying to have, that's testing a lot of technical skill of the analyst. Do they understand this protocol, that protocol? Can they understand and pull out the relevant data? And then for anyone that's worked in incident response, and you typically do it, I know, about a few weeks after the actual research itself.
You forget what you did, right?
Yeah, you then have to try and remember actually what took place, write it in English, and most incident responders I know struggle with English, and that's their first language. And you've got to sort of then write it out and try and make it make sense to whoever your end customer is. This is, again, a great example where we're able to use AI to, number one, speed that whole process up, which is a great way of sort of getting to the final outcome that you want, but also to bring improvements, better clarity, better effective delivery of the information. Again, looking at it in Darktrace, you've got on the left-hand side all of those individual alerts, trying to understand what they mean, but giving you in the middle then a much more clear English, human-readable breakdown of what we think has happened. Sort of full explanations using a whole range of techniques to pull the information together. And then if you're a visual learner, using that graph theory, that clustering, to give you a much better example representation on the right-hand side.
I think this slide is really good just because we wanted to talk about the pyramid of pain, which of course is a very commonly used approach and methodology. And we wanted to then sort of layer on different approaches, right? And you have traditional sort of indicators of compromise, you run it through, and that's threat intelligence driven. You have behavioral based now, a lot of people are talking about that, and that's where we sort of fold in. But of course you want to take advantage of understanding the adversary, and also sort of making up your own hypotheses. So for us, we try to sort of use a lot of different techniques to understand what's going on across the threat landscape. And it's been able to prove that we've been able to detect a lot of things before that exploits happened. And so we just wanted to show, like, hey, there's a lot of opportunities for everyone as defenders to take advantage of AI now. So.
Yeah. And I think from our perspective, we've been big sort of believers in, if you go back to the pyramid of pain and some of the origin story of it, effectively, some of these things at the very, very bottom are things you can write rules and signatures for. You kind of need prior knowledge in so many cases. You need explicit prior knowledge of an attack that did exactly this. You need that sacrificial lamb kind of mindset. Somebody needs to get compromised first for us to all benefit from. Now, I don't know about you, but I don't want to be the sacrificial lamb. And I think there's an element there of going, well, actually, how can we get slightly further beyond that? How can we get to the point where nobody has to get compromised first for us to know ways in which we can detect it? And so trying to move up the pyramid of pain, trying to move up to where we're moving away from really specific atomic indicators to general behaviors, and using behavioral-based AI to really understand what's going on, and not necessarily by looking for things that we know are bad, but by contrast looking for things that we know don't make sense for that environment, that basically aren't good. And that massively lowers the threshold for detection, and it allows us to start looking at much more lower fidelity signals of a compromise in an environment, and hopefully detect it much earlier on.
Yeah.
So I think that's us.
Yeah, that's it.
Thank you.